Okay, so far, in this chapter and before section 10, we've talked a lot about Earth's history and how it was made and the different species and the time, eras, and that we've had these mass extinctions occur through here. But what we haven't talked about quite yet when we talk about evolution is how animals are classified in the classification system, which was actually a really important task because as we're going through the fossil record and finding all these different species, there's millions and millions of them. And we didn't have a unified or proper way to classify them or categorize them so that we actually knew what the heck we were talking about. And so we started to develop this system of classification, and we're going to start with the Linnaean classification. And this is basically a way for us to understand how species throughout Earth's history were able to be classified. And so when we're talking about them, a fossil found in Europe could be the same name as a fossil found in North America or South America or Africa. Before the classification system, you might call it a bicycle in the United States because it has two wheels, a seat, and handlebars. But they call it a toilet in Africa. I mean, they didn't have any rhyme or reasoning, and there was no common language for these. So it's really important that we came up with a classification system. And so our early classification systems is what we know as taxonomy. A taxonomy is a branch of biology which basically names and groups organisms according to characteristics. And not only the characteristics that they have now, but evolutionary characteristics. And so our first classification system was started by Aristotle, and it was the first grouping of organisms together. And so basically our organisms were grouped into land dwellers, things that lived on land, water dwellers, and air dwellers. And so plants were placed into three categories based on the different stems that they had. New organisms being discovered. We found out that Aristotle's system it wasn't okay. It was really inadequate. It had so many loopholes in it. Well, if you think about this, there is not one organism that lives only in the air and doesn't ever go to the land or the water. It doesn't make sense. And then when we talk about plants, well, based on their stems, some plants don't have stems. So where do they get classified? And so their categories weren't specific enough. The common names did not describe a species very adequately, and the names were too long and too hard to remember. So then people started coming up with common names for things, and there was really no system with Aristotle's. It kind of went out the window as soon as it came in. It was a right idea. It just was very, very poorly executed. Okay, then Linnaeus came along. He was a Swedish botanist, and specifically with botany, he worked on naming plants. And then this taxonomy actually worked really well to not just name plants, but other organisms as well. So, with this, he developed a hierarchy or ranking system for classifying organisms based on characteristics that we know. And this is the basis or the groundwork for our modern taxonomy system. And he's actually known as the father of modern taxonomy for this. And so he came up with the 7 levels of organization, which are kind of nice to know. So in a Linnaean taxonomy system, it doesn't account for a few things. One is molecular evidence. When we talk about molecular evidence, we're talking about DNA, RNA. It just didn't exist during Linnaean's time. He had no idea what it was, so he couldn't base a system off of it. It's only based on physical similarities. Well, if you think about this, in the 1700s, it's not like we had microscopes everywhere. We could look at things at a molecular level. We didn't have DNA technology or forensics of any type. So you only had physical characteristics or physical similarities. And we know that now DNA or molecular evidence is way better. And so if we look at the family below, this is all family of the canines. These are all examples of different types of canines. Where in the Linnaean classification, we might not have had all of them in this family because they didn't have those same molecular things. Okay, and so physical similarities are not always a result of close relationships. And so this looks kind of like a little fox that we have here, and it's actually a red panda. And so it is genetically more similar to a panda bear than it is to a fox. And so, but with the LINNAEAN classification system, his physical characteristics would have put him in more of a fox than it would have put him into a panda category. So genetic similarities are way more accurate at showing evolutionary relationships than physical characteristics. So we do use some of the basis for LINNAEAN's classification system and basically how to categorize it. His system is still somewhat being used today. However, we do have now a few more things, such as his first system had all organisms only divided into two kingdoms, Plantae, which is plants, and animals, Animalia. Now we have more. So we have Protista, we have eubacteria, archaeobacteria, we have fungi, Plantae, and Animalia. And so we have 6 categories instead of 2 kingdoms now. But he did use some of Aristotle. These were also Aristotle's. So here's our main system. We have kingdom, phylum, class, order, family, and genus. And so a kingdom would be, in his LINNAEAN classification, would be divided into plants and animals. We just went over the 6 that we have now. A phylum is a smaller group of your main divisions. Then we have our classes, which are divided phylums, then orders, and then into families. And then genus and species are kind of nice, because genus and species are actually how we have our modern names. Now, in LINNAEAN's classification, phyla and family were not actually in there, but they're added now. And so we needed 2 more subdivisions, and phyla was nice because we have a larger subdivision. So we can divide things into, like, the kingdom Animalia is divided into vertebrates and invertebrate. And so chordata, which is vertebrates, is much larger group, and then we can break that down. And so it's a little bit easier to classify and use a taxonomy guide. And so here are some ways to remember this. And the page number is wrong. I do apologize, because your book's got a PDF and it's not the same. I think the PDF version of your book is like page 36 or 35. And so basically, so King Philip came over for grandma's soup. You've probably heard King Philip came over for good spaghetti. And so these are just a way to remember how to name this. And basically we use a bio-nomenclature, which is a 2-part scientific name. And so that's what every organism has, such as we are Homo sapien. And so it's genus and species. It uses Latin words. Its scientific names are always written in italics, the first word being capitalized. It is the genus first and the species second. Genus is the name. So like Homo means same. Sapien, which for us would be our descriptor, or how we know that, how we know who we are, what they are. And so again, our bio-nomenclature is a 2-name system. And so it's our genus and species. And so when we talk about like Escherichia E. coli, we're talking about the genus being Escherichia, E. coli being the species. And so there's always a 2-part name for this. A genus includes 1 or more physical similarities of a species. Even though they may be closely related, we'll see that a genus is always capitalized. A species is a descriptor and is the second part of the scientific name. It is always lowercase. It always follows the genus. It is never, ever, ever written alone. You would never write for a human sapien. Well, that doesn't tell us what it is. You have to have that Homo sapien or Escherichia E. coli. You will see sometimes that the first descriptor or the genus might be just a capital letter abbreviation for it, like E. coli is the abbreviation for Escherichia E. coli. Just a shortened way of putting that, but you still have the genus descriptor there for those. Now, this is really important because the LINNAEAN classification system was the basis for this, and it helps scientists not only to communicate how these species are named, but it gives them a similar name, so that we know what they are. We're not calling it something different in Europe and Asia that we call it in the United States. It's all the same. And so it allows for us to communicate. Some species have very similar names. However, that's why we have our common names too. And so here's an example of a few of them here, where you have Escherichia E. coli, or sorry, when we talk about like things like Escherichia E. coli, you have the genus and you have your species. And so we can see that some of these might have similar names, such as our puma, Concord, which is our mountain lion, our cougars, and our puma. And so they're really similar. All of those are actually very similar structurally to one another. However, there are smaller differences between them, but they will have similar scientific names. If we talk about Escherichia coli, Escherichia coli actually has, I think, 8 variations of that species. And so we can see that sometimes they do have these common names which are very similar. And so we're going to pause right now. You can upload the second video because we're going to run out of time on this one. You can look at 511 part 2.